I have two fields of research, biomonitoring and physical acoustics. In this work, we are determining the acoustic and thermodynamic and viscometric properties of the systems and solutions and electrolytic solutions and thank you sir, and liquid solutions, mixtures, binary, ternary, and then by way of measuring the ultrasound speed, the densities, viscosities, and then computing the various thermodynamic derived parameters, acoustic and viscometric. And we have worked on very many systems. Few I have brought here, and these studies few properties like thermal expensivity, etc., give us the information directly. Otherwise, it makes us easy to calculate these parameters, which are not cannot be measured directly by any instrument directly. And these parameters gives an insight into the structure breaking and making properties of the solutes and the solvents. As what systems I have got, some are biological molecules, biological components, and some are liquid components, some are electrolyte components, and then we determine these parameters, then determine the coefficients and smoothing coefficients as a part of statistical analysis, and then gives the interpretations. So this is all the study about that, whether the particular component which we are using, it is these kind of studies are useful. The significance is that they are useful in nowadays we are talking of more and more of eco-friendly and economic environmental pollution and safeguards against it. So to replace the organic conventional solvents with so such properties are important in the industrial and uses, and wherever these such solvents and solutions are used or binary or ternary mixtures are used, in particularly in unit industries, unit processes. So this is a kind of work, and when we use it for biological systems, we say that this is bioacoustics. So some like nucleic acids, which are important biological human molecules. Sound speed data we are determining by an ultrasonic interferometer, and that works on the principles of acoustic resonance. And there is a quartz crystal, and the acoustic waves which are generated, and we know what that frequency about 20,000 cycles is not audible to human ear. So that is the frequency that we are measuring, and whenever the two frequencies match, that is and this shows a deflection in the meter, and we measure the distance, and then we measure by a formula the sound speed 2d upon sine theta. So this is a way. This is why we are how you are using these acoustic, viscometric, and thermodynamic data as tools for assessment of properties of solutions. These are about sound waves which are not audible to human ear, and this is a principle on which this sound speed determination is based upon. These crystals can otherwise also be used for this, and what the properties we can assess, what structure making and baking properties we assess are on the basis of these type of interactions which we anticipate, that dipole-dipole in polar-polar systems, dipole-induced dipole in polar non-polar systems, ion association complex, charge transfer complexes, interstitial accommodation in one another. So by virtue of the components, their structures, their molecules, we come to a conclusion that these kind of interactions might take place, and these kind of interactions are reflected in the properties which we determine by theoretical relations. There are standard theoretical relations which we are using, and by virtue of those standard theoretical relations properties, we give the interpretation. This is the ultrasonic interferometer, is the instrument basically which generates, and refractive index studies are also being done, and these are the theoretical relations, and these are the derived properties which we are calculating, computing from the measured experimental parameters. All these properties, internal pressure, and these all gives an insight. The values of these properties, positive, negative values, the excess values. Excess values means ideal and difference between the real. Theoretically, we compute that if they were there, then sum total of the individual properties of the components, and the experimental what we determine, and the difference between the two is the excess properties. The excess properties are negative, means the sign of the excess properties and the magnitude of the excess properties gives an idea about the type of interaction that might take place. This is how we calculate the sound speed. What instrument we are using is this to operating at 2 megahertz is the applied frequency, and sound speed is frequency into wavelength, and distance traveled is what I said. Then acoustic resonance takes place, and electric reaction is generated, and this is shown as a deflection in the meter, and the distance traveled by the screw, yeah, distance traveled by this uh, uh, is known then, and then that is calculated, U is calculated by this formula. And this is a this thing, this is a circuit. These are the literature values, and what we have determined of these values experimentally, how you this is a viscosity measurements, density measurements. These are calibrations. These are refractive index measurement. Now I come to these are how do we make the solutions, and these are the result discussions. I come to directly the conclusions of how we conclude. In some systems where the excess volume is negative, it is negatively. Say it is in bromobenzene and some alcohol, then it is followed by 0. So we conclude that B is the negative from the entire volume, and this is less negative, and then turns to positive. This shows that there were interactions which are weakened, and this can be ascribed to the fact that isoaction is a higher alkane, and higher alkanes mean there are more alkyl groups. So this is how we say that what type of interactions can be present. Similarly, isentropic compressibility is also calculated. Free length, excess free length is also calculated. Excess free volume is a very important property, and the difference, the variation to the concentrations are shown here, and these depict negative values for excess isentropic and excess intermolecular free length, and they suggest some kind of interactions between these, but they are of weak magnitude because of the sign and magnitude. Sign is negative, this means interactions are there, but the magnitude is less, that means weak interactions are there. And sign is positive, means dispersion forces. Let's say dispersion forces means supposedly they were originally hydrogen bonding between the two components, and if you add a solute to it, make it a ternary component, then the addition of that component, what is, it's break the hydrogen bonds between them or break the interstitial structure between them. So then it becomes positive, and we say the dispersion forces are playing their role. Then these values, this is excess volume is entire range. In this system, it becomes negative. We have already done. These are the smoothing coefficients which we calculate, and this gives you the accuracy, authenticity of the determinations. Then we have also applied theories, theoretical theories. These are semi-empirical, empirical theories to determine the sound speed. In addition to experimental determination of sound speed, which we are doing, and then we find that out of the 4, 5 most popular empirical theories in this system, experimental values coincide more with the free length theory. That means that they agree with the concepts of the free length theory, then with the impedance dependence relation theory, then with the nometer, and then the Van Deel-Wangel, which is in which we found most of, highest deviation. Now we come to the next system. Say this is a aquasuria and guanosine system, and this again we have these kinds of we prepare the solutions in the entire over the entire concentration range and determine all these values. This is triethanol, triethylamine, and 1-decanol, and here again we get these kind of results. These suggest that structural effects like dipole, dipole, and dipole induced dipole type of interactions with the polar, polar, and non-polar components exist. Interstitial accommodation is also possible. Deviation of this delta Ks means isentropic compressibility, excess volume, excess free length is attributed to structure making effect, and this is confirmed by positive deviation in these, means this is negative deviation and this is impedance. So this is positive deviation. So these are both relate to each other. So we conclude in system that weak interactions or dipole induced dipole type may be present in the system. Possibility of interstitial accommodation in the large molecules cannot be ruled out. Increase in temperature, because we have done these studies in all systems we have done in 298 Kelvin, 3083 and 308 Kelvin, and it doesn't have a significant effect. This is with toluene and dodecanol. Again, these are all the variations. These are all the curves which show the differences. These are the smoothing coefficients. Then this is the application of the empirical relations, and this is the variation. This is for another system, ternary, and we have weak interactions of dipole induced type. These type of conclusions we again draw. This is here. This is an adenosine and aqueous solution at 298 to 318. The value of density first decrease with increase in concentration of adenosine, and then decreases, which may be attributed to increase in interaction and then decrease in interaction. Then by using the density, we calculate the 5E, partial molar volume, and partial molar volume values are positive indicates the presence of greater solute-solvent interactions, and decreasing values of phi compressibility, apparent molar compressibility with increasing concentration show strong solute-solvent interactions, but then increasing values indicate that solute-solvent interactions, solute-solute interactions are also present. This is with other glycine, L-arginine, L-lysine, threonine, glycine, arginine, different at different temperatures, at 3 different temperatures. These are the results. And this is with another glycine plus D-L-alanine in mixed solvent DMF water system. This is mixed solvent studies, and in this we conclude that large positive values of 5E0 for solvent system indicate presence of strong solute-solvent interactions. Positive value of SV indicates a strong solute-solute interactions, and the hydrophilic interactions between solute and solvent is also reflected. This all goes to say that these components are leading to structure making properties, and wherever we have dispersion forces, they have structure breaking properties. I think this is these are the publications, and thank you for a passive hearing, and thank you once again Dr. Arvind Yadav sir and the organizers of the Science Congress to have given this opportunity, wonderful opportunity to share my work.